Hi guys, my name is Mr. Lead, and today we're going to be talking about energy efficiency. Now, before we dive into that, let's do a quick recap of the last lesson. Last time we talked about energy and the different types of energy. We talked about how some energy can be stored, like chemical energy and elastic energy, but some energy we witness as it's being carried out, such as thermal energy or sound energy, kinetic energy, electrical energy, and light energy. Let's have a think about this even further. Say you take your two hands, take your hands and rub them together. What type of energy are you using to move your hands? That's right, you're using kinetic energy because you're having to exert energy in motion. Now, this kinetic energy is being transferred or transformed into two other types of energy. What are those types of energy it's being transformed into? Have a think. Can you hear something? Well, if you can, that means you're transforming that kinetic energy into sound energy. So that's one type of energy that's being transformed. The other type is thermal energy, because I'm sure as you move your hands together, they're getting warmer. What type of thermal energy is being transferred here? Well, have a think. Is it radiation? Is it radiating thermal energy? Well, no, because we're not feeling any heat radiating from our hands. Is it convection energy? Convection thermal energy? Well, no, we're not seeing convection because that's only existent in liquids and gas. So therefore, we're seeing heat being conducted across our hands as we move them together. And so when we're talking about energy efficiency, we talk about energy that's being transformed or transferred from one thing to another. And usually when it's transferred, you don't have a very smooth transition from one type of energy to another type of energy. Usually it goes from one type of energy into two or three other types of energy. We transferred kinetic energy here into heat energy and sound energy. So ideally, if we're wanting to warm up, we only want to transfer kinetic energy into heat energy, but we're losing some of that energy in sound energy instead. And this works the same for appliances as well. Say you have a car, you want your car energy to, you want your car engine to be transforming energy into the stored energy in the fuel, the chemical energy in fuel. You want to transform that into kinetic energy to get your car moving. But some of that energy gets transferred into heat energy. And so we call that wasted energy because we don't want that heat energy. We want the useful energy, which is the kinetic energy. So every sort of appliance will have a purpose for the energy that it's trying to get as an output, but also usually have some energy that gets wasted as something else. So let's take this a bit further with some more examples. Say you got a power plant. This power plant collects 100 units of coal, that's chemical energy, and it converts that into electrical energy. But as it's converting it, it loses some of that coal as heat. Some of that energy gets lost as heat, or some of that energy gets lost in light. And so that's 62 units all gone. You're left with 38 units whereas you've started off with 100. And so as those 38 units get transferred along the power lines, even more energy gets lost. Say 2 units gets lost as heat energy. And once it gets to the house, and it's finally being used in a light bulb, we've only got 36 units left, where we started with 100. But in those 36 units, the light bulb doesn't just produce light, which is what we want, it produces heat. And we don't want it to produce as much heat, but it's using 34 units of energy for heat, and only the final remaining 2 get used for light. So we see that only 2% of the energy we started with here in the coal is actually being used for light. So much of that energy was just wasted. And so this is what energy efficiency is. It's a measure of how much energy we get as a useful output compared to the overall energy we had to start with. It's a good measure to know how much energy is wasted. We calculate this with this formula here. We take the useful energy output and we divide that by the energy input, and we times it by 100. So this is just a percentage. Let's understand this further with some examples. So let's take this remote control car, for example. Firstly, have a think, what type of energy is the remote control car getting from a battery? That's right, it's getting chemical energy. Now, it converts the chemical energy into electrical energy as it goes through all the wiring in the remote control car. We're not thinking about the remote control, by the way, we're just thinking about the car. And it converts that chemical energy into electrical energy into 3 different types of energy. It converts it into kinetic energy because it's moving in terms of the wheels. It converts it into sound energy because you're hearing that car go. And then it also converts it into heat energy. You might not be able to see the heat energy, but more often than not, whenever you see something move, it's exerting some heat energy. Maybe those tires are losing a bit of heat energy into the ground. It's convecting into the ground. So those are the 3 things that those are the 3 outputs of energy. Which of these is actually the useful energy the energy that we actually wanted to see? That's right, the kinetic energy, because we want to see the car move. So if we take our formula from before, the useful energy, that was the kinetic energy, we divide that by the total energy input we had to start with, and we times that by 100, we'll get the energy efficiency. So the useful energy was just the kinetic energy. That's all that we wanted. So, hang on. I'm going to do a formula here. So we have 1,050 joules. Divide that by the energy input of 18,000 joules times 100. Whoop, I'm going over some writing there. Equals, let's do a bit of a calculation, 58.33%. I'm rounding to 2 decimal places there. All right, 58.33%. That's only 58.33% of the energy that the battery possessed is actually being used for a good purpose. The rest of it is being wasted. That's right. All right, let's look a bit further at some more examples here. Let's look at the energy efficiency of this toaster and this flat screen TV. Now, the work is already done for us. It's already highlighted the energy that's been needed here. So we're converting electrical energy into thermal energy to heat up the toast. So we take 55 kilojoules divided by 60 kilojoules times 100. That gets us 21.66 kilojoules. Now, if we look here at the flat screen TV, we've actually got 2 different sets of units here. The output here is in joules instead of kilojoules. So we need to actually convert this down. We need to divide this by 1,000. And we get 90 kilojoules. All right, whoops. So if we do the calculations here, there we go. We got 90%. This TV is 90% energy efficient. That's actually pretty good. So all appliances, you'll find in Australia, all appliances have a sticker on them to show the energy rating that it has. It shows how energy efficient this appliance is. Now, you could very well just go along your day and just think, look, I don't care if the toaster is 50% energy efficient or 90% energy efficient. Does it inhibit its job of toasting toast? And it could be 50% energy efficient and toast just as well. That's very reasonable. It could do that. But the thing that you need to be more concerned about is the fact that if an appliance is less energy efficient, that means it's going to need more electricity or more chemical energy or more of an energy input to do its job. So if it's an electrical appliance, it's going to take more electricity. And if it has a lower energy efficiency, you are going to end up having to pay more money for your electricity than for the appliance you just bought. So ideally, you want to fill your house with as many energy efficient appliances as possible to save money on electricity. One of the biggest uses of energy in a home is the energy needed to keep a house cool during the summer and warm during the winter. So in order to reduce energy and to be more energy efficient, you need to think about how you can reduce the amount of energy you use during those key periods. So main thing to think about is if you have to use a heater and if you have to use an air conditioner, are the air conditioners and heaters you're using the most energy efficient ones? If you've got an oil water heater, which uses a lot of energy, is it the most energy efficient possible heater you have? And perhaps the more energy efficient ones are more expensive, but they will be less costly in the long run if you're using less electricity. Now, there are also ways you can prevent even using heaters and air conditioners in the first place, and that is some simple things such as just preventing door leaks and insulating your house. And even planting trees on the west or south sides of your house. That creates shade for your house, which keeps your house cooler during the summer. So all these ways help improve your energy efficiency. Some other ways that architects have to think about is the way you orientate the windows in your house and the way you orientate the house itself. So if the windows of your house are facing the northern and eastern sides instead of the western or southern sides, it's not going to be as hot or as cold in summer and winter. And same for the room. So if you make sure that all the rooms that need sunlight are facing directions which can get sunlight, then that would be most optimal. And you can keep the smaller rooms that you don't use as much, such as the bathrooms facing south or those sort of directions. You can also make sure you use coverings, such as verandas or pergolas. All of these things help reduce the amount of energy that you would even need in the first place, the amount of input energy you would even need, which therefore reduces the overall energy efficiency. Okay, so that's energy efficiency, guys. Thanks for watching.